So if I am going to use the parallelogram method to resolve these resultant vectors in green, I'm going to take my red pen and make a couple dots to transfer the y-ness of each one of these resultant vectors back to the y-axis and the x-ness of each one of these resultant vectors back to the x. Then I will make a vector on the y-axis, and I'll count how many boxes are involved going up, and so that means in this case it's plus 5. I'll do the same for the resultant vector on the left. I'll make a y-axis vector, and I'll count how many boxes, and that's plus 4. So that's all the information above the line, but then I see that this vector is -6 downward. I'll do the same thing in the x-axis, so the resultant vector on the right, I find that it's positive 6 newtons to the right, and then if I look on the resultant vector on the left, this one is -7 newtons. At this point I can start figuring out net force. Net force in the x-axis equals all the forces in this direction plus all the forces in the opposite direction. And this is where positives and negatives become very important. So net x equals -7 is going to the left and positive 6 is going to the right. So my net in the x is -1 Newton. Well, I've resolved the x, now let's resolve the y. So my net force in the y-axis equals all the forces going up and all the forces going down. I add them up. So if I apply the numbers that I got, I have positive 4 plus positive 5 plus a -6. And I'm going to put this in parentheses so I can keep it straight. So 4 plus 5 is 9, but then if I subtract 6 from it, I get a positive 3 newtons. At this point, I can start drawing my resultant vector. That's what this box is here for. So if I start right here, I see that the net force in the y-axis is plus 3, so I'm going to draw a little plus 3 vector here. And then it's -1 in that direction along the x-axis. And so if I start from the origin, the place where I started, I can draw my resultant vector goes in this direction. Now the parallelogram method is really good at figuring out the resultant direction, or the result direction. And so in other words, the direction that this force is applied is up and to the left a little bit. Unfortunately, the parallelogram method doesn't help me very much when it comes time to figuring out the magnitude of that force. And that's where Pythagorean's theorem really comes into its own. And Pythagorean's theorem is a squared plus b squared equals c squared. Now what's cool is a and b can be either the red or the blue vector. I get to pick. And so I'm going to choose 1 squared plus 3 squared equals, and the thing is I don't know what the c is. So I'm just going to write it. 1 squared is 1 plus 3 squared is 9 equals c squared. I'm going to move up here so I have a little more space, and 10 equals c squared. I'm going to square root the right and the left in order to get rid of the square root, and I find that c equals 3.1622 and then if I'm going to make it nice and neat, I'm going to call it 3.16. And I put it in green because it is a resultant vector. it's kind of in that direction.